Okie dokie. In this problem, they say, which is the correct graph for the function f of x equals 4 to the x plus 4? So the first step I'd probably take is finding the y-intercept of this function. And we do so by plugging in x equals 0. So when we plug in 0, we get 4 to the 0 plus 4. Now, it's very important to understand that 4 to the 0, or anything to the 0 power, is equal to 1. So then we'll have 1 plus 4, and we get 5. So f of 0 equals 5. In other words, when x equals 0, y equals 5, which tells us this is the y-intercept of this function. So we're looking for a y-intercept of 5, crossing the y-axis at 5. So A checks out, B checks out, C does not check out. It looks like it crosses at like y equals 3, right? And then D does not check out. It's like y equals 7 maybe, okay? So A and B both cross at y equals 5. So now you could take a few different approaches. You could memorize that 4 to the x would look something like this behavior. Or you could think about how if you plugged in, this is the approach I might take. If you just plug in a different x value, for example, if you plug in x equals 1 to this function, let's analyze what we would get. So f of 1 would be 4 to the 1 plus 4. 4 to the first is just 4, and 4 plus 4 is 8. So what we just found is that y should be 8 when x is 1. Which graph has this ordered pair? At x equals 1, the y value should be about 8, which looks about right on option A. But on option B, at x equals 1, this y value is less than 5 right here, right? So less than 5 is not going to equal 8, so A must be our answer. So anyway, that plugging in x equals 1 method should work every time. But again, if you wanted to, you could think about 4 to the x should look like this. 4 to the negative x would look like, let me make sure I get this right. I think it looks like this. It would be decreasing. And that might be all you need to know. Let's do one more though. All right, so correct graph for this function, 5 to the negative x minus 2. Again, I'd plug in x equals 0 first. We get f of 0 is equal to 5 to the 0 minus 2. Anything to the 0 power is 1. We're subtracting 2. 1 minus 2 is negative 1. So this is our y-intercept because we plugged in x equals 0 and got y equals negative 1. So this has a y-intercept of 1, not it. This might be negative 1, that checks out. This might be negative 3, that does not check out. This might be negative 1, so that checks out. And then if you want to use the trick, 5 to the negative x should be a decreasing function, so that would lead us to B. Otherwise, I would recommend just plug in x equals 1. Can never go wrong. So plug in x equals 1, we get f of 1 is equal to 5 to the negative 1 minus 2. So that would be 1/5, or 1 over 5 to the positive 1, minus 2. And 1/5 minus 2 would take us very, very close to negative 2, right? So it would take us to, I don't know, in terms of decimals, it'd be like negative 1.8. Okay, so the y value should be negative 1.8 at x equals 1. And so we can see that option D, right at 1, the y value is probably more like 3. And so that's not negative 1.8. But on graph B, at x equals 1, the y value is definitely less than negative 1 because that was the y-intercept. And so negative 1.8 is valid in terms of, matching that graph. Hope that makes sense. That's all I had for this one. Here's a glimpse at both. All right. If you have questions, let me know.